y equals 3x over square root of x squared minus 9. Now, for us to solve this question, we need to look at the denominator. This denominator, when the value becomes equal 0 or less than 0, it will be undefined. For example, if we have 0 here, 0 squared is 0. So what we have down here is minus 9. And you know that you cannot get the square root of a negative value. If we have it as 1, if x is 1, 1 squared is still 1. We get root of minus 8, which is, but whenever we get it greater than 3, because 3 squared is still 9, 9 minus 9, 0, square root 0 still will not work. But whenever we have 4, 4 squared will be 16. That's when we'll get a value, a positive value here. So what it means is that whenever the value of x is less than or equal to 3, then we'll know that it will be undefined. Because of that, we'll say that the domain is when x is greater or equal to 4. So that's the domain. The next question that follows says, compute f of g for x and g of f of x, given that f of x is x minus 1, then g of x is 3x squared plus 1. What this thing simply means, for us to compute this, it simply means take the value of g, put it in whenever we see x in f, because f is x minus 1. So since here is f, we're going to substitute it for the value of g, and this is the value of g. So for us to say f of g, it will now be, instead of saying x, we'll say 3x squared plus 1. Then the remaining of f is now minus 1. That's what it means, f of g. So since there is x here, we'll remove it, replace it with g, that is this, then we'll write the remaining. Had even there's another x again, we'll still replace that x, substitute it with still the value of that g given to us. That's how it is. So since this is just x minus 1, what we'll just do is substitute this for the value of g, then minus 1. So what we're going to have is 3x squared. 1 minus 1 is 0. So our answer is 3x squared. The second one says g of f of x. So for us to get g of f, what we're going to say is take the value of f, put it in g whenever there is x. So our g already is this. So we write 3. Instead of x now, we'll put it the value of f, which is this. So we'll say x minus 1. And remember, it is squared, so we square. Then the next one plus 1. Plus 1. So this is the same thing as saying 3 into x minus 1. X minus 1. Then plus 1. We'll say 3. Here is x squared. Here is minus x. Here is minus x. Here is plus 1. So we now still write this plus 1. So we have 3x squared. We have 3x squared. So this multiplied 2 of this. This also multiplied 2 of this to get this. So x, we now have this will give us minus 2x, then plus 1, also plus 1. Now we open up the bracket and say 3x squared, that's 3 times this, 3x squared is minus 6x, then plus 3, then plus 1. So what we now have is 3x squared minus 6x plus 4. Next question says, find the inverse function f of x equals 1 over x minus 3. The first thing we need to do, let's say step 1. The first step is to, first of all, change this. This is the same thing as y. So we'll say y is equal to 1 over x minus 3. That's the first step. The second step will be to express this equation in terms of x. If we express it in terms of x, that's making x subject of the formula, we'll have that x is equal to 1 over y minus 3. The next thing is to put it in linear. If we put it in linear, it means cross multiplying. So we'll have x times y minus 3 is equal to 1. If we open up this bracket as step 4, we'll have this is xy, this is minus 3x is equal to 1. The next thing is, let's say v, step 5, which is now making y subject of the formula. If we make y subject of the formula first, we'll have xy equals 1, this coming over, plus 3x. Therefore, y alone will now be 1 plus 3x over x. This is the inverse of this function. So this is the inverse function for it. And if we want to write it, we'll write it as inverse function of x is 1 plus 3x over x. So this is the way to present it, inverse function. This question says, evaluate the limit of the function f of x equals x squared minus 5 plus 6 over x plus 2, x minus 2 as x tends to 2. If we want to solve this, we'll say limit as x tends to 2. First of all, if we go through direct substitution, 2, we're going to have 2 squared minus 5 plus 6 over then 2 minus 2. We're going to get 0 as a denominator, and that will be undefined. That will be undefined. So because of that, we don't want to have 0 as a denominator here. So what we're going to do is to factorize. And if we factorize limits as x tends to 2, we have x squared, first of all, minus 5 plus 6 over x minus 2. We're now going to check what are the two numbers. If I add them, I'll get minus 5. If I multiply them, I'll get 6. They are minus 2 and minus 3. So what I'll have is limits as x tends to 2, x minus 2, x minus 3 over x minus 2. You can see this one looks like this one. So we'll have limit as x tends to 2, x minus 3. We can now substitute the value of 2. You keep writing limits until you make that substitution. So we'll now have 2 minus 3. So the answer is minus 1. The next question says evaluate the following. Limit as x tends to 0, sine x over x. Now, this is the second question. Let's do the first one. As x tends to 0, if you go straight and just say 0, direct substitution, you have sine 0 over 0, and this will be undefined. This will be undefined. So what we're going to do first of all is to differentiate them separately. So if we differentiate them separately, if we differentiate sine, we're going to get cos over, if we differentiate x, we're going to get 1. So we'll have limit as x tends to 0, cos, if we fix it, cos 0 over 1, and cos 0 is equal to 1 and 1 over 1, so the answer is 1. The B part says limit as x tends to 3, x minus 3 over square root of x squared minus 9. Then if we do by direct substitution, we'll have limit as x tends to 3, then we'll have x minus 3 over square root of 3 squared minus 9. This will be 9 minus 9, you get 0. This will be 3 here. If you fix the values, 3. So you have 0 over 0, so which is undefined. So we can actually factorize this and say limit as x tends to 3. You have x minus 3 over square root of x squared. Instead of saying 9, we say 3 squared, the same thing as 9. And you know that difference of squares that says a squared minus b squared is the same thing as a plus b, a minus b. So we can say limit of x as it tends to 3, the numerator x minus 3 over denominator we have here x minus 3 x plus 3. Since one entity is dividing them, this can be expressed as limit as x approaches 3, x minus 3 over square root of x minus 3, then we can put this, then x minus 3 over square root of x plus 3. Now this can be written as, say, x minus 3 squared over square root of x minus 3, then root x plus 3. This can be written as this. So we bring this. So the next thing we can do is that this will be square root. Sorry, this will be square root, because if you look for the LCM, it will be their square root. So the next thing we can do is this can take one of this. So what we're going to have is root of 1 is left over 3. Then root, okay, let's put the root down to all of them. So x plus 3. X plus 3. Limit as x tends to 3. Limit as x tends to 3. So the thing we can now substitute the values and say square root 3 minus 3 over 3 plus 3, which will give us square root of 0 over 6. The answer is 0. This question says, if f of x equals 2 raised to the power x, show that f of x plus 3 minus f of x minus 1 equals 15 over 2 f of x. That's the first one. Let's look at it. Now, the function we're looking at is that f of x is same thing as 2 raised to the power x. Having noted that, let's pick the left hand side, the first one. Let's determine f of x plus 3. f of f plus 3 is going to be 2 raised to the power x. Now x now is x plus 3. X plus 3. This thing is the same thing as saying 2 raised to the power x times 2 raised to the power 3. Now 2 raised to the power 3 is 8. And 2 raised to the power x is the same thing as f of x. So we say 8 f of x. So having obtained that, let's look at the second one there, which is f of x minus 1 is equal to 2 raised to the power x. The x is now x minus 1. So what we're now going to do is, this is something as saying 2 raised to the power x times 2 raised to the power minus 1. This thing is the same thing as f of x, and this one is the same thing as times 1 over 2. So this is 1 over 2 f of x. 1 over 2 f of x. So this is f of x. This is 1 over 2. So this is this. So we can now say, therefore, f of x plus 3 minus f of x minus 1 is equal to, what the value we got for this is 8 f of x. The value we got for this is 1 over 2 f of x. Since f of x is very common, so we say 8 minus 1 over 2, then we'll say f of x for both of them. So having gotten that, we'll look for the LCM. The LCM is 2. We'll say 1. This is the same thing as over 1. 1 into 2 is 2. 2 times 8 is 16. Minus 2 into 2 is 1. 1 times 2. Sorry, 1 times 1 is 1. So this is 15 over 2, which is equal to 15 over 2 f of x. So we've been able to prove it. The second question on that same one says we should prove that f of x plus 3 over f of x minus 1 is equal to f of 4. Now, what we need to do here is, if we cross multiply, the only way we can prove this is if we cross multiply, we will have that fx plus 3 is equal to f of 4 times f of x minus 1. Now, in the previous one, we found this to be 8 f of x. And we've also found this to be, let's say, fx plus 3 is equal to this. And fx minus 1, we also solved it in the first one, is 1 over 2 f of x. So what is left for us to solve is f4. f4 is equal to 2 raised to power 4, which is 16. From the equation, what we're now going to have is, we just say on this side is 8 f of x is equal to, here is 16 times, here is 1 over 2. So what we have is 8 f of x is also equal to 8 f of x. So this is for this is for f of 4, then this is for this. So this is this is this. So the next question says, if y is x3 over 2x2 plus 1, obtain the y dx. Now we can say let x3 be called u, and let 2x squared plus 1 be called v. And we can use quotient rule. Quotient rule says differentiate the u with respect to x times keep v constant with respect to x minus keep u constant with respect to x, then times differentiate v with respect to x all over v squared. That's the quotient rule. So if we do that, what it means is differentiate this u. This is our u. If we differentiate u, we're going to get 3 times this, 3x squared. Then we keep v constant. Our v is 2x plus 1, 2x squared plus 1, minus, this is constant, x3 times, then we need to differentiate v, and our v is this. So if we differentiate this, we're going to have 4x plus 0, because if we differentiate any constant, it doesn't have x, it will be 0. So over, our v is 2x squared plus 1 all squared. So from here, what we can do, we can write this and say 3x squared 2x squared plus 1 minus, if you multiply this, you have 4x4 all over 2x squared plus 1 all squared. So this is the answer.